everyone, and welcome back to the channel. Today we have part 2 of a 3-part series covering the Google Stadia announcement. This part is a technical deep dive where we go into the engineering underpinnings of how all this works. There are some video clips in here, but primarily I took a bunch of stills out of the video so I could take my time on each one and kind of explain what's going on. So grab a drink, sit back, relax, and enjoy this technical deep dive video talking about Google Stadia and all of the amazing engineering behind it. So as you can see from this screenshot from the video here, the presentation for Google Stadia was done live at GDC, and it was in San Francisco. The introduction was actually given by the CEO of Google, Sundar Pichai. And one of his slides here points out something really crucial to know about Google Cloud, right? So when you're talking about doing streaming of any kind, proximity matters. And proximity is how close are you to the person who's trying to consume your service or stream your stream or whatever it is. So what this map is showing is that Google Cloud is in 19 different regions, has 58 zones, and it's in 200 plus countries and territories. So what that means by looking at the kind of red dot areas here is that if you're in a pretty densely populated area like North America, South America, and Europe, you'll have no trouble accessing this service. What you can also see is there's large areas like in Northern Africa that have no connectivity whatsoever. China looks like it has very little as well. So that's all going to matter. But for the majority of people who are going to be consuming this, I think we'll see towards the end of the presentation here that it launches in US, UK, Europe, and maybe one other place. So I think they pretty much have that covered here in this map, but we'll see some more information pertaining to this kind of distribution as we go further through the video here. So one of the points that Sundar made is that they want to build a game platform for everyone. And they kind of harp on this throughout the video because what they're trying to say is this is not just for a small subset of people. And that serves two purposes. One is they're trying to say they don't want to leave anybody behind. They want anybody who wants to use this service to be able to use it. But the second thing is they're trying to say our market, our total addressable market, right? The number of people who can play on this platform is as big as possible, meaning we can draw the most number of players, which tells developers, hey, you should build games for our platform because we're building the platform for everyone, right? So we're not being like Xbox or Sony trying to carve out their little niches in the market. Project Stadia and Google want to have every single gamer in the world play on this platform. And that's a pretty lofty goal, but if anyone can pull it off, it's Google, right? So this is the logo. I think the official one is colored, but in this presentation they had a black and white version. It kind of panned to this, and if you haven't noticed yet, these are just screen captures I've taken from the video. I am going to intersperse some video clips. You've probably already seen one at this point. You'll see a few more, but mainly I'm just screen capping because I didn't want to keep pausing the video to kind of talk about it. This way is a lot easier because if I go slide by slide, I can kind of explain what's going on. So Phil Harrison here points out that there are 2 billion plus players around the globe playing video games, right? So that's pretty significant. That's nearly a third of the global population. So that's the addressable market. Again, this part right here is the pitch to developers, but it's important to know from a technical perspective because this platform has to be able to serve potentially up to 2 billion people, okay? So Project Stream is actually something I participated in. I was, and we'll get into a couple of slides here in a second that show what it was, but essentially it was in 2018, it ran through the Chrome browser. So I played it on a PC and a Chromebook just to test it, and it worked flawlessly on both of them. It was Assassin's Creed Odyssey, a AAA title running at 1080p and 60 frames per second. And I can tell you from playing it, it actually did. So, that's what it is. Here's a funny little slide just saying, hey, it's incredible. I opened Chrome at my work laptop and was playing Assassin's Creed Odyssey, streaming in seconds with next to nothing for input lag. This is the exact same experience I had. I opened up my laptop, opened my Chrome browser, and I was playing instantly with nearly no lag. I opened up a Chromebook, same thing. Chromebook had a little bit more lag, but my Chromebook is actually very, very, very old. It's not the original one, but it's maybe like the second gen, and we're way into them now. They're a lot more powerful. And even on that old piece of hardware, it ran just fine. So this slide is highlighting the initial partnership between Google and Ubisoft. So while this was called Project Stream, right, it's now called Stadia. So Project Stream was when it was in development under wraps, and they were just kind of testing it, right, with Ubisoft and Assassin's Creed. And then when it went public, it's now being called Stadia. So this is just highlighting that Ubisoft was the official launch partner. And these are just some slides here showing, Assassin's Creed Odyssey. And again, it played really well. I can't complain at all. I had no problems with it. So this slide is pitching to developers. And what this is saying is they said that they asked a bunch of developers, what are the problems that we can help you solve? How can we make it easier for you to make games on our platform that you can get a lot of players involved in? And what the developer said was, help us to create, help us to scale, and help us to connect. Meaning, make it easier for us to make the games or to create the games, right? Give us the tools to make it easier. Give us the tools to scale. So instead of having, 1 or 2 player games, instead of having 100 player games like Fortnite, what about 1,000 player games? What about 2,000, 10,000 player games, right? So that's scale. And connect is just be able to get to connect to it from anywhere, right? Don't make it to where you have to have a console or you have to have a PC. Can we connect from any location with any device, right? And that's kind of the pitch that's going on here. And by the way, I love Phil Harrison's shoes that they're color matched to the graphics in the presentation. That's on point right there. So what this slide is showing is the kind of interconnectivity they built in between YouTube and this new service. And we'll actually get into that towards the end of the presentation as well. This is just showing from the front end. So what he says here is, imagine you're on YouTube and you end up at an Assassin's Creed Odyssey trailer on the official Ubisoft North America, page. And you think, man, this game really looks awesome. I want to play it. You see there that little icon to the left in the middle says play now. The idea is you click on that, and then this comes up and it says, hey, do you want to play? Click on play. And the next thing you know, within seconds, you have instant access. You're in the game, right? And again, I do recommend that all of you guys go watch the actual video. These are just my screen captures. The video does it much better justice than what I'm doing here. But this is a technical deep dive. This isn't a watching the video thing, so please go watch the video. But again, the point here was instant access, right? So you're not actually downloading it. You're not waiting for it to install. You're not waiting for updates, patches, whatever. All that's handled on the servers. The minute you click play, all it does is load up the stream, make sure you're connected to it, and it's instant access. With Project Stream, I want to say that it was within 5 seconds at most. You were in the game. That is not at all how games work right now. When even on PC, which is better than console, it's still not that fast. So this thing is saying a whole new way for games to be discovered, and this is true. So instead of game publishers trying to do everything through the traditional methods of advertising, they can put YouTube videos up, right? Trailers and just live gameplay sessions straight to their YouTube pages and allow the games to be discovered very easily. But not only that, because this ecosystem is in all of Google, it can show up in search ads, it can show up in video ads, it can show up in Google search results. Literally anywhere a user is looking for stuff, you could potentially serve up an ad or serve up a way for the game to be discovered. And then again, there should be a play button. They can click on it and then they're right in the game. And here we have a clip of Phil Harrison holding the new Google Stadia controller. I'm going to play a clip here in a second that actually illustrates not only this controller, but how controllers operate in Stadia. And this is very important because this is one half of the piece of how this whole thing works, right? How are you getting controller inputs up into the cloud to the Google Stadia service? And what are these various buttons?
I'd like to introduce you to the newest member of the Google hardware family, the Stadia controller. This is your gateway to the best of Stadia. It enables you to access the full Stadia experience, and there are many advantages to the Stadia controller. And the first is that it will connect through Wi-Fi directly to the game that is running in the Google data center. The Stadia controller identifies which screen or device you want to play on and links it with your game session running in the cloud, ensuring the highest possible performance and the best experience for players. In addition to the standard functions you'd expect to see on a modern game controller, the Stadia controller features two very important new buttons. The capture button is for sharing and saving your game experience back out to YouTube. The gamer can choose to share their experiences starting with a click of this button to themselves, to their friends, or to the world. They are in control. And the second one is the Google Assistant button. Pressing this button allows players to immediately access the controller's built-in microphone so they can get help from the assistant for special in-game features integrated by developers. Our goal with Stadia is to help fuel developer creativity at every level. And next, we'll take a look at the incredible computing power we have custom built into our data centers that will further accelerate innovation.
So here we get into the actual engineering meat of this video and this presentation. So Majd here is standing in front of the same map that you saw Sundar in front of at the beginning of this video. Same thing, it's highlighting all the presence locations where the Google Cloud is, and he's kind of delving into the actual engineering aspects. Now, he went through them in reasonable detail. I'm going to go a little bit slower so that we can kind of get some good detail on what all of this means and how it functions and how it actually makes Stadia work, so that you guys understand why it is that I think Google is actually going to be successful with this effort as opposed to the efforts of OnLive, Gaikai, Sony, and others in the past. So as it says here, there are 7,500 plus edge node locations around the globe. That is critical. What that means is that there are so many edge nodes that users should be able to connect to one anytime they want, high bandwidth, low latency, right? An edge node is not something small, right? Edge node is an entire node of this service, meaning it's probably comprised of several servers, several dozen servers, several hundred servers. We don't know because we don't know the actual engineering backend, the numbers. Google doesn't give those out. But suffice it to say, with this number of edge nodes, they can host a lot of gaming sessions, probably millions of them concurrently. And this picture I just threw in here because it looked really cool. It's one of the Stadia data centers, and as you can see, it's, customized. These aren't your regular servers from Dell or HP. These guys built this specifically for Stadia. Looks really cool. The lighting obviously looks cool and all that. But we're going to get into a little bit more of what's actually in all of these racks that these servers are running in. So going back to the previous point about Project Stream, Majd here is showing that when we did the original test, and I say we because I participated in it as one of the beta testers, we were getting 1080p 60 frames per second with stereo sound, which I can attest to because I tested it and I participated in it, and it ran incredibly well. Stadia at launch is going to have up to 4K 60 frames per second HDR, right, and surround sound. So this is essentially Xbox One X level quality running on a cloud instance. Now, one thing to pay attention to here is where it says up to 4K. That is really important. Now, here's the thing. I don't think that means that the Stadia service itself might do 4K, might not be able to do 4K. I think the service itself is going to do 4K, period. I think what the up to 4K means is, can your internet connection actually handle a 4K stream, right? Because here's the deal, right? When you're talking about latency of things going back and forth, right? When you're doing something on your controller, like let's say you're pushing a button to jump and it's going up to the cloud, then at that point, the gaming instance has to render your character jumping on screen and then it comes down. Okay, at the point where the render happens, before it's fed downstream back to your TV or tablet or whatever you're playing on, all of that's the same, right? So the keystroke on the controller going upstream, telling the cloud instance, I'm jumping, and then the cloud instance saying, okay, I need to render a jump, that's all the same. What then happens is what differentiates the difference between the 1080p and the 4K. The GPU actually has to render it at 1080p or at 4K. It's not going to render it at 4K and then downgrade it to 1080p as it streams it. It's not going to render it at 1080p and try to upscale it to 4K as it streams it. It doesn't work like that. In order for the latency to remain low, the stream has to originate at the resolution that you want and be streamed at that resolution. So it's coming down at 1080p or it's coming down at 4K, right? Not a blending there. So What that means is if your internet connection cannot handle a 4K stream coming down, you're going to get choppiness, you're going to get artifacts, you're going to get all kinds of stuff that doesn't belong there, and it's going to look like crap, right? And Google doesn't want you to experience that. So it's probably going to test your connection, figure out, hey, are you able to actually run a 4K stream? And if not, it's going to put you to 1080p. But if you can run a 4K stream, it'll put you at 4K. I watch tons of 4K content streams, so I think I'm going to be okay with this, but either way. But yeah, full 60 frames per second HDR, that's amazing, right? Because I'm playing 4K HDR on my Xbox One X. It's like a completely different world when you play games in HDR. Surround sound's cool too. I mean, I don't know that it doesn't really matter to me, but maybe for some gamers, the positioning of things in the game, it matters, but you're going to have it. And the next slide is really what blew my mind, right? So all this stuff was awesome in the presentation up to this point. There was a lot of cheering and clapping when it said 4K 60 frames per second. This one I think got the most clapping. 8K 120 plus frames per second. It doesn't have an audio thing here. I'm assuming it's still going to be able to do surround, if not Dolby Atmos or something like that. It is the future. And again, this is nothing to do. I want to kind of make something clear here. I don't think that it's saying the future because this platform can't deliver that now. I firmly believe that Stadia can deliver 8K right now today to your house. What I don't think is that there's enough internet connectivity out there of that class to be able to actually deliver it, right? I don't think anybody's streaming 8K content yet. I know there are some 8K TVs out there, just a handful, but this thing will be able to deliver the games at 8K. And again, going from 1080p to 4K to 8K doesn't matter in terms of latency, right? It doesn't, because it's a one-way video stream. It's being rendered in the cloud. What matters is that the engine rendering all this in the cloud is able to do it fast enough and send it down to your device that you're playing on fast enough that you don't notice any kind of lag, right? And that's entirely dependent on your internet connection. And we'll get into a couple of slides later where I'll explain why this really matters and why it's so unique how Google is doing this as opposed to, let's say, OnLive or Sony's Gaikai or any of these other services that didn't quite make it before. This right here also blew my mind. Now, obviously I knew this was a capability, right? If you're running this in your data center, right? So the little cloud icon in the middle, that stands for the data center. You're running the stream in there. It's doing two simultaneous streams. The one going to the left over here, it says up to 4K 60 frames per second to a controller. That controller represents you. That doesn't literally mean the controller. That means the device you're playing on, including the controller that you're using to play it. The one to the right is 4K 60 frames per second. Notice how that one doesn't say up to. And I think this is where I kind of figured out what the differentiation was here, right? So it's saying 4K 60 frames per second to YouTube. Now, that's not necessarily streaming to YouTube, although I think it can and I think it will. It's also saving the video. So I'm thinking what's happening here is you have the option, or you will have the option, to either stream it live or just save it straight to YouTube at 4K 60 and then go back and do whatever stuff you need to do and then publish the video later. Either way, what it's trying to tell you is this is not ephemeral, right? This is not use it and lose it, right? As you're playing, it's also recording it to the cloud at the same time, at the same speed, so that you can go back later and either make clips, publish it to YouTube, so all your viewers can watch it or whatever. And I think that's another reason why I said here's the differentiator. When you're talking about YouTube and Stadia, these are on Google's backbone, right? Meaning they're on Google's high-speed fiber-connected data center network, which means they have ultra-high speed, ultra-low latency. So they're guaranteeing 4K 60 frames per second on your recording. But again, the up to part on the left here, going to you, I think that's highly dependent on your internet. And I think that's what they're trying to couch here, is they want to make sure that they don't say, hey, you're for sure getting 4K 60 just like your recording going to YouTube, because they don't know what your internet connection speed is, right? But the great thing about this is, even if you're playing at a reduced, let's say 1080p or up to 4K, but I'm going to say 1080p or 2K, whatever. You're playing on something less than 4K, 60 frames per second, because Google has to adjust that stream so that it gets the right performance characteristics, you're still streaming and or recording at 4K 60 frames per second. So your viewers are seeing a 4K 60 FPS stream regardless. That's amazing, especially if you're a streamer or a content creator like I am. That's just blow your mind amazing. It's like saying, hey, don't worry about your local equipment. Even if it's not the best, your viewers will get a unique and awesome experience watching you play regardless. This is huge for content creators. So here I think he's speaking towards the developers again, saying the data center is your platform. And what that means is a platform is typically something that you do something on top of. So like Xbox is a platform to play games on top of. PlayStation 4 is a platform to play games on top of. PC is a platform to do all kinds of things, including play games on top of, but also, create content and all kinds of stuff. These are platforms. So, but these are local platforms, right? You usually have your PC, your console, whatever, in your house, in your home, and your, iOS is a platform as well. Android, those are in your possession. What he's saying here is that this platform is now in the cloud, in the data center. And by the way, let's kind of make that connection right now. When we're talking about the cloud, the data center, the internet, functionally they are the same thing. There are differences, and we don't need to get into those because that's very, very philosophical engineering speak. But for the purpose of this video, when they talk about the cloud, the data center, or the internet, they're functionally the same. And then there will be a differentiation in a couple slides in the future here, where we actually show how the internet is now different than what it was before, specifically with this. So this is kind of awesome. This means everything that's happening here, all of it is taking place in the data center. You're not on the hook for any of that hardware anymore. All you need is a phone, a tablet, a PC, a whatever, right? Even a Chromecast, a little $50 dongle that connects to your computer, and a controller, and everything else happens in the cloud or in the data center. That's amazing, right? So this slide here shows another awesome thing. There was a part of the video where they show that AMD is the official partner on this project, and there's a reason for that. AMD is way ahead of Intel in creating combined CPUs and GPUs. AMD calls them APUs, but essentially it's a CPU and GPU on one chip so that you don't have to have a separate GPU inside of your machine. Now, on a PC, you typically have a CPU and a separate GPU, but some Intel chips, well, most Intel chips, except for a few, have integrated GPU or iGPU, but it's not powerful enough to game. AMD CPUs or APUs have Vega graphics integrated, the new ones, and then the older ones had other graphics engines integrated, and they actually could game. So, for example, your Xbox One and Xbox One X, PS4 and PS4 Pro are all running custom AMD APUs. It's CPU, GPU on one chip. And that's because it's a console. They want it to remain really small, not get too hot, not get too loud, but still be able to game. So what AMD delivered here is pretty impressive. The next slide will kind of show you, but let's just kind of go through this real quick. So the GPU has 10.7 teraflops of power. And the next slide will show you how much that is in perspective. 56 compute units, and very expensive but very fast high bandwidth memory 2 memory, or HBM2. It has a custom x86 processor running at 2.7 gigahertz, hyper-threaded with AVX2. Again, they don't specify this as an APU, but I think it is just by looking at the specs here and also understanding what AMD has done for Xbox and PlayStation. I don't think it makes financial sense or data center scale sense for Google to be putting a bunch of CPUs and actual like NVIDIA GPUs in a rack. That makes zero sense. What makes more sense is to have some high-end APUs that can actually game and sticking those in the rack. And then if you need more power, just combining them together using multiple of these APUs to scale the power up. And they do show that later on, referencing GPUs by themselves, but it is what it is. And it says and it points out here it's a custom x86 processor. Some people are speculating that maybe this is an Intel x86 processor and somehow that AMD has a separate like GPU on a chip that's in there. We don't know because we haven't seen the actual engineering schematics for any of this stuff, and I doubt we will. But Again, AMD has custom x86 APUs, processors, and GPUs in all of the gaming consoles. So my guess is that's exactly what's in here. And it's the next generation of stuff, not the stuff that's currently out on the market, right? So they partner with Google, obviously, to do some serious field testing of it. And I hope that Google shares in the future what these things are. It's a competitive advantage, so I'm kind of thinking they're not going to do that. But maybe, a couple of years down the road, once they've upgraded to newer infrastructure with faster stuff, they can kind of say, okay, well, this is what we had at launch. And then we can kind of know, because that's of interest to someone like me who really loves the engineering aspect of this. So the memory that's in there, again, 16 gigs of total RAM. And if it's HBM2, that is very expensive RAM. Up to 484 gigabyte per second transfer speed, really fast. And L2 plus L3 cache of 9.5 megabytes. That doesn't seem like a lot, but I mean, maybe in this context you don't really need that. Either that or that's a what do you call it? An error on this presentation. But who knows? So this was another slide that blew my mind. Okay, PS4 Pro 4.2 teraflops, Xbox One X 6.0 teraflops. Right, that's almost 50% faster than the PS4 Pro. The Stadia instance, one instance, 10.7 teraflops. That is more than the Xbox One X plus the PS4 Pro combined. That's an immense amount of graphics power. So it kind of just blows my mind to see this kind of performance. So again, I'm assuming this is an APU, but even if it's not, even if it's a separate GPU on a chip that AMD sold to them, the fact that it gets 10.7 teraflops is pretty good. Another thing that I find personally important about this entire effort is that all of Stadia runs on Linux using Vulkan API. So they don't have to worry about the inefficiencies of Windows, viruses, just Windows slowing down over time, bogging down, just junk everywhere. It's on a streamlined Linux kernel with Vulkan API on top of it. This is as lean and as high performance as you're going to get in terms of the computing infrastructure. So thumbs up to Google for going down this route as opposed to trying to make a bunch of Windows instances and make it work. At launch, they're going to be supporting Unreal Engine. They already are, right? So that's really, really good news. And I know that they're in the process of working with Unity to try to get theirs on board, which is amazing. Also, they're going to be partnering with Havok to do the physics on this platform. And then this next slide just shows all of the partners that are involved right now. So you'll recognize a bunch of these names, right? So we already talked about Unreal, Visual Studio for doing the development, Vulkan, Unity. There's AMD as the official partner for launching. CryEngine's going to run on it at some point. Audio Kinetic, right? Umbra, there's Havok over there again. There's just a bunch of stuff that is going to run on this either at launch or over time. And this makes, again, this slide is mainly for developers. It's trying to show them that all the tools they already use to make games are going to be compatible at some point. So it's kind of drawing them in. But it's important for us as gamers and reviewers and whatnot to know about this. I mean, I'm a developer, so this matters to me anyway. But for the rest of us, it matters because it shows that Google's putting a lot of effort to make it easy for developers to get the games onto this platform, right? And developers want two things. They want it to be easy, and they want there to be a lot of players so they can buy the games. So Google's trying to hit both of those at the same time. In this part of the speech, this was also talking towards the developers, but I thought it's important for us to cover here because it's also part of the engineering, which is saying, I think what Maj said, and I'm kind of paraphrasing here, is that if you're developing for Stadia, you can develop in our cloud, you can develop in your cloud, or you can develop at your desk. And this is kind of the three options showing right here. So the first, the leftmost is their cloud, meaning you can probably rent a Stadia instance in there or several to kind of do your development on. The second one is they'll probably ship you a physical. That's what this looks like on the middle one here, the red Stadia box. It looks like a 1U server that's just shipped to your data center and put inside. So what this is for is like a developer or not a developer, but a development company that is really, really paranoid about security and doesn't want any images of the game leaking out before the game comes. They don't trust to put it in a public data center. They want it in their own data center. That's fine. That's what that second image is for. The last one, I think, is more for like indie developers. It's at your desk, right? So a big development house is going to want to have a bunch of servers in a data center, but if you're like a couple of maybe 5 guys doing indie development, You probably can't afford that server, so you can get one or two of these Stadia desktops that have, the hardware inside of there, and then develop against that, right, and get your game published. So here, this is just saying you have an option for all three, and this is, again, something that's really important to us as gamers to know. Google is trying to come to the developers on their terms and saying, hey, we want you to develop for this platform, but we're not going to force you to do anything. You have a choice here. You pick what you want to do. We're going to meet you on your terms. And that's really good for us gamers, because that means we're going to get more games, better quality delivered on this thing. And that just means a lot to us, because the last couple of years have been sort of garbage in the industry for various reasons, right? So I feel like Google's taking the right approach here, trying to meet the developers on their terms and make them happy, because they are the most important. They're the ones creating the games. This slide I just put up here because it's awesome to see id Software on here. I played the original Doom many, many years ago, and have played every Doom since then. I love the series. So anytime I see id, I realize they made other software, other games and stuff, but to me, id is Doom and Doom is id. So seeing this was like, I knew what was coming next, right? There was no like, oh, I wonder what this is going to be. If I see id, I see Doom. And so what this here is showing that the new Doom that's coming out, you guys have heard of it, it's Doom Eternal. It is going to launch on Stadia. And they actually had demos of it running on Stadia at GDC. Unfortunately, I wasn't able to make it to GDC this year. I was traveling on other business, but I wish I could have, because I absolutely would have been playing on that Doom Eternal there. So this was super impressive, right? AAA game, FPS, twitchy game, meaning that latency's got to be super low. Launching with 4K HDR at 60 frames per second. It's launching with Xbox One X performance or PC performance on this service. That just blew my mind. It's hard to even believe, but again, and I know there's a lot of pundits out there saying, oh, they don't believe any of this, it's all a lie, Google can't deliver this, but if anyone can deliver that, it's absolutely Google, and I believe they will. And I hope they do, right? Because it's good for the gaming industry, for more competition to exist, for better platforms, for innovation, and all that kind of stuff. So I really hope Google succeeds here. So what you see here is the emblem or the logo for Underwriter Laboratories or Underwriter Labs. What this is a private entity that electronics companies will send their stuff to for testing. And what I mean is all kinds of testing, performance testing, heat. Sometimes they'll set things on fire to show if the whatever the product is able to extinguish itself, or if it's just going to burn in a mad inferno. That's what UL does. So if you go look at any appliance that you have, somewhere on there is going to be a UL emblem, and all that means is that it was sent to those labs to be tested for various things to make sure it's safe and it actually does what it says it does. So what they actually did was got a testing suite from Underwriter Labs that actually was able to test the functionality of the GPU and the GPU scaling in Stadia. So the next couple of slides are just showing you the difference, right? So you have on the left, you have a single GPU instance. On the right, you have multi-GPU, right? So the left is what you would see on a typical console, right? An Xbox One, a PlayStation 4, a low-end gaming PC. And on the right is what you would see typically out of a high-end gaming PC running like a 1080 Ti or a 2080 Ti, or running those in SLI, right? So it's able to get a lot more detail and definition, and that's kind of the what they're showing you here, the difference. The left one is absolutely playable, right? And it looks fine, especially when it's moving. Like this right here was a standstill screenshot, right? But when it's moving, you almost can't tell. But when you stop it, you can tell, right? So here again, left is single GPU, look at the water. The right is multi-GPU, look at the water, right? So water physics are very hard to do. A lot of complex GPU resources. But also look at the rocks in the background. Look at the shading, look at the lighting. It's just so much better on multi-GPU. And what I'm guessing Google's going to offer you different tiers. You can probably get a single GPU instance very, very cheap so that you can play. And then a multi-GPU will cost you a little more and you can play your games at better resolution, right? We have a couple more here I think this is the last one illustrating the difference, right? Left versus right. Again, now this is just a personal preference. I don't care how real a game looks. I actually don't want my games to look realistic. And I know that sounds kind of weird, but I play games to escape reality. If the more it looks like reality, the less I want to play it. So I would much rather play on the left-hand side single GPU version than the right-hand side, right? That's just me, but there are a lot of gamers that are, pixel peepers or whatever you want to call them, who really, really care that every little drop of water is rendered, perfectly and whatnot. And hey, for you guys, you'll get it with multi-GPU. So now we get to what I consider kind of the meat of the technology, right? This is the critical difference and why I think Google is going to succeed in this versus the other guys who have tried before. This here shows you the typical pathway that happens when you're playing a game, right? And it's showing you from a console, but it could be a PC as well. You have a game player using a controller. That controller is connected up to a console either via a wire or Bluetooth or wireless, 2.4 gigahertz. Then that console is connected to the internet. That's the ISP here. And then over on the far right, you see cloud provider and game server. So not Stadia, but let's say Sony's Gaikai or OnLive or one of these other ones that are out there. Now, what this picture here is showing you where it says transits. When you connect to the internet, it's not as simple as your computer is connecting straight to a web server. That's not how it happens. And this is where we get a little bit technical, but I'll try to keep it simple yet technical so you guys understand what happens. So when you want to load let's use loading a web page as an example. When you click on a web page and you want to open it, right? What happens is your browser does a lookup on the back end across the internet. And what it's doing is looking for a couple of things. Number one, it's trying to find out what's the IP address of that server, right? So if you put in google.com, there's an IP address attached to the back of it. Now, I don't actually know what that IP address is right now without looking for it, but let's just say hypothetically it's, 67.68.69.70. That's not real. We're just saying it is. So in order for your browser to actually render a web page to you, it has to connect to that server, and it connects by the number. When you type in google.com, the browser doesn't care what google.com is, and the server is not advertising itself as google.com. What happens is there's a thing called DNS, domain name system, right? And what that does is translate google.com into a number, 7.68.69.70 or whatever it is. There's a translation that happens, and then your browser is able to go and say, I need to connect to 67.68.69.70, right? It no longer is talking about google.com. When you type in google.com, it goes out to a DNS resolution server and says, what numbered address is google.com? The DNS server responds with a number, and then your browser connects directly to that number. Okay. When I say directly, it's not actually directly. Transits here is showing what happens. The internet is not a series of tubes. It's not a, direct connection, right? So your browser does not have a direct fiber or copper line to that server. What the internet is a bunch of routers and servers that have a predetermined agreement amongst each other as to how they work. So when you want to connect to something, you don't go straight to that thing. You have to cross several devices, typically routers, right? But you have to cross them. And so what happens is there's a negotiation that happens where when you want to get to this other server, a bunch of routers will advertise their routes and the quote unquote transit costs. I won't get into that. If you want to Google it, you can Google, internet transit costs and all that. But suffice it to say that what happens is your ISP determines the most cheap or the least costly route to route that traffic across to get to the other server. And it does this by knowing what all the routers are advertising for their transit costs as the thing goes across. So it is possible for you to get, like, if you look at this circle down here, I'll kind of move my mouse around it. If you look at this circle here and the bottom left, and then this one over here on the right, the last circle before you get to the cloud provider, it is possible that you could have connected directly between those two, but it's not likely because that route is probably very expensive, quote unquote, to get across. Instead, you're going to take a roundabout way to get there, and that's what we call transits or hops in internet lingo, right? and there's typically multiple hops for you to get from one place to another. The point here is that each of these transit points or each of these hops adds latency. Okay. So if your connection to a router is typically 1 millisecond, every transit hop you get is going to add another millisecond or two, because we're also talking about how fast are these routers. They're all different speeds, right? So this could easily exceed 10 milliseconds here, this transit, right? Let's just say they're 2 apiece, right? Well, there's 6 of them. That's 12 milliseconds getting across, and that's not counting the actual server itself, right? So that's 14 or more milliseconds. That's not going to give you too good of performance. So this is why a lot of these services have failed in the past, because this methodology of how the internet works is not what you want for gaming. You're not trying to get the cheapest route. You want the fastest route, and your ISP in general is not going to want to do that, right? So what Google is showing here in this slide is this is how the internet typically works, and it is slow. And slow, I'm talking milliseconds here. I'm not talking about like seconds, minutes, or hours. This is, fractions of seconds, okay? So Google is saying this methodology here is slow. It doesn't work for this technology, and that's why we're not using it. And this is the part that really, when I saw this, I was like, oh, wow, I see what they're doing now. So again, I don't work at Google, right? I don't have back-end information. I don't know exactly what they're doing. But here's what I do know. Over a decade ago, Google set up a bunch of what they call peering arrangements with the ISPs. Now, let's get a little bit of background here. That model I showed you earlier of stuff going across the internet and saying there's transit costs for all of that, when data's moving, it's costing, right? And the ISPs are just trying to get themselves in a position where the amount of data leaving their networks and coming into their networks is roughly the same. If they can get to that point, they're kind of net even, and they're not losing any money, and they're making money off of everybody paying for internet. When that ratio is imbalanced, meaning when there's far more data coming in than leaving, they're now paying a lot because it's someone on their network requesting data as opposed to streaming data. Now, there's costs in both directions, and again, this can get very complicated. But what this picture is trying to illustrate is Google is not using that approach. So again, early on, Google set up what they call peering arrangements with the ISPs. And what this means is they put connections, fiber connections, directly between Google data centers and the Google data center backbone straight to the ISPs, the big ISPs, right? So Cox, Time Warner, Spectrum, Comcast, AT&T, CenturyLink, Level 3. I mean, we can go through the whole list, right? So the point is they've got direct connection. It's almost like a private internet. It's not actually a private internet. I don't want to describe it that way, but it's almost like a private internet. And by the way, Amazon and Netflix have this same kind of arrangements in place, and I believe Microsoft does as well. But I'm not sure about Microsoft, and that's actually key to how this streaming thing is going to roll out, because we've heard of Project xCloud from Microsoft recently. So if you go back to this picture, you see all the transit hops. All of those are adding milliseconds of latency to the traffic, right? So when imagine this is Project Stream now, and you get rid of, let's go back to this slide over here. So here in Project Stream, you see Game Player, ISP, Google Data Center. You're missing console, you're missing transits, but otherwise these are the same, right? So the device itself is being taken out of the equation, right? Because in this new way of doing it, the controller is connected directly to Wi-Fi, assuming you're using their controller. I know it says it works with other controllers, and they probably have a different way of connecting, but Google didn't specify it in the actual video. What they did specify was how the Google controller works, the Stadia controller. So let's use that as the example. So here what it's saying is, I got the controller connected directly to the internet and directly to the Google Data Center. And the Google Data Center is streaming everything down directly through the ISP back to me in my other device. So I no longer have the latency being added by the intermediary device here, the game console, and I also don't have all the latency being added by all these transit points. Okay, so these peering arrangements allow Google and others to have private networks essentially that can run very fast, very low latency without taking a ton of transits or hops across the internet. And the reason I know Google's using these networks is because they said in the actual presentation, your data is secure. It's not going over the public internet. So if you're not going over the internet, you have to be going over a private network of some kind. And the only one that I know of that Google has are peering arrangements with the ISPs. It's possible they have other stuff. Again, they haven't put it out in public, but it would be a brilliant move to use the peering arrangements that they already have with the ISPs. I believe that's what they're doing here. So imagine now you as the player have taken all this stuff that adds latency out of the equation, and it's literally just you, your ISP, and Google doing business. This is amazing. And I think this is why this is actually going to succeed this time, as opposed to every other time we've tried to do this in the past, is that there is a layer of technology being used here that has not been used for this purpose before, that is fundamentally faster than the actual internet itself. Okay. So I think this is a key here. And Sony and Nintendo, I'm sorry, you're never going to have this, right? You just don't have that kind of money. You don't have that kind of presence and pull. Microsoft, on the other hand, has Azure data centers also all over the world, their own cloud, just like Google. They're not as big, but I mean, they're big. So Microsoft could possibly have all of these peering arrangements in place already and be doing the exact same thing for xCloud. We'll find out when they make their announcement. I think we're going to see it E3. But for now, this is, I believe, how Google's solving this, and it actually is a brilliant way to approach the problem. So moving on, this is just showing how there's connections between all kinds of stuff here, right? So you can see there's different types of controllers, there's mice, and what I think he's trying to illustrate here is that each of these are separate from the actual gaming device itself, right? So the controller is its own device. Whatever you're viewing or consuming your game on is a secondary device. So it is possible to link all of these devices together, right? So, for example, 100 people playing Fortnite on Stadia at the same time, they could all have individual controllers and be connecting to 100 different Stadia instances, but in the data center, the 100 Stadia instances could be co-located in the exact same, rack or whatever of the data center and get ultra low latency. It is possible that you get a faster and better gaming performance out of a game being run entirely in Stadia than what you're getting right now out of playing Fortnite on a PC or PUBG or Apex or whatever it is you want to play, right? So I think he's just trying to show on this kind of graphic here that there's a million ways to connect the devices and the endpoints and all that kind of stuff. So pretty impressive if you ask me. And another thing, because all of this stuff is running entirely in the cloud, right? So the only input you're allowed to put into the cloud is controller input and or mouse and keyboard that are being converted to, sort of like controller input. There's no cheating or hacking, right? You're not able to get into the Linux operating system. You're not able to modify code. You're not able to do any of that stuff, right? And again, it's streaming it down live. All the processing happens in the cloud, so it's not like you can hook into a stream and be watching what your opponent's doing. No cheating, no hacking. Again, just this is, it's not like you're getting this additionally. Like, it's not like Google built in anti-cheat or anti-hack. This just comes as a result of everything happening in the cloud and you not being able to actually touch the underpinnings, right? So cheaters and hackers, what they typically do is hack the operating system on either the Xbox or the PlayStation or the Switch or PC, and then they get into the executable file for the game, they hack that, then they're able to cheat. In this new method of gameplay, you can't do that. You can't, because of the way it's designed, right? Another thing that was amazing that got a lot of cheers and ovation from them is that they're going full cross-platform play, period, from the get-go. So if a game runs in Stadia, but it also runs on PC, Xbox, or PS4 or whatever, you can play with those people. Now, going back to the previous slide, they can no longer guarantee this in cross-platform, right? Because again, if you're playing PUBG, Fortnite, Apex, whatever it is you want to play, and you're playing with people that are on PC, they can hack the PC side of it easily. But what we're saying here is that it is fully cross-platform from the beginning. And it's kind of a shot at Sony, really, if you want to think about it, because Sony's trying to put up the wall garden now. They see they see the writing at the wall on the wall at this point. So this is kind of saying, hey, we're cross-platform from day one. So if you're, Epic Games that makes Fortnite, if you're PUBG Corporation, if you are EA and Apex, whoever, as a developer or a publisher, you want to come to our platform because we're going to let you play with everybody, right? So the total number of gamers who can buy is much larger, okay? This area interested me a lot as well, which is the coordination between Stadia and YouTube. This really, really matters because most of us who are content creators that are gamers are also uploading to YouTube. It's true, we might be streaming to Twitch or Mixer or some other place, sometimes YouTube, but most of us will also upload the video to YouTube, right? What this is saying is this thing has a tight integration with YouTube, meaning as you're playing, as you saw in this, several slides back, there's a simultaneous 4K 60 frame per second stream being stored to YouTube, period, right? Now, I'm sure you can turn that off, but it's being done, which means you can stream live on YouTube at very high resolution, and then you can publish the video later. If you didn't happen to stream, but it's stored there, you can publish it later. This is really bad for Twitch. And I realize Twitch is like the juggernaut of the industry right now, but if this platform, Stadia, gets any kind of traction, which I think it will, and because I know I'm going to be playing on it, it means that I'm probably not going to be streaming to Twitch anymore. I'm going to stream exclusively to YouTube because it's all hooked in and it's happening at 4K 60 FPS, without fail. I don't have to think about, I don't have to have capture cards. I don't have to worry about OBS. I don't have to deal with any of it. It does it all for me. And as a content creator, that makes a huge difference. So this slide here is saying 200 million plus logged in daily active users watching gaming on YouTube. That's a lot of people. 50 billion plus hours of gaming content watched in 2018. That is huge, right? I mean, that's around 7 hours for every man, woman, and child on the planet. Obviously, not all of them are watching it. But if you divide 50 billion into 200 million, you'll see how much each one of those people are watching. So there you go. The most connected gamer experience ever. This is true, right? Just by virtue of the fact that these two are from the same company and they're tied together on a very high speed, low latency backbone in the data centers, means that these two are going to connect almost as if you had a streaming PC connected, to your regular PC via, high bandwidth connection, and there's a 4K capture card and all that. Imagine all the technology it costs, all the technology needed to stream at 4K 60 FPS. Imagine all that. You're talking $2,000-$3,000 PCs, right, with all of this stuff in them, capture cards and whatnot, and a high bandwidth internet connection upstream and all that good stuff. You don't need any of that. All you need is a controller and a Chromecast, and the rest will be handled for you. It's amazing. There's no other way to describe it but amazing. So what this slide is showing is Google Assistant added into it, right? And Google Assistant plays, so far from what I can tell, a minor part, but it is kind of important, and I think the role of it is going to grow. So what does it do, right? Google Assistant, you guys already know what that is if you're familiar with Android. If you're not, it's similar to Siri or Amazon's Alexa or Microsoft's Cortana. It's a digital assistant that does stuff for you. And in this case, it's usually by saying, "Okay, Google." But you can reach the Google Assistant from the actual controller. You guys saw that in the clip we showed a while back. So what is it trying to show here? Well, this guy here is playing, or this individual here is playing this game, and they're stuck. It's one of the Tomb Raider games, and they're stuck. They can't figure out how to get past this tomb or this level. So they push the Stadia, the Google Assistant button, and say, "How do I beat this tomb?" And then it says, "Here's the top result." And what it's showing here is it pulls up a YouTube video of somebody who's played through that part and then shows it to you so you can see how they beat the tomb, and then you can do it yourself. Now, this doesn't seem that important or that intuitive, but just take a second and step back and understand what had to happen here, right? You're playing a video game, you're in stream, okay, in Stadia. You ask the assistant for help. The assistant has to do a couple of things, right? So it knows what game you're playing. Let's just say it's Rise of the Tomb Raider. It knows that much. But how does it know where you are in the game, right? So it has to apply AI or machine learning to look at the scene you're in and let's say look at the last couple of seconds of video, and in very fast time go onto YouTube and find a fingerprint from another video that very closely matches what yours is, right? So so that's how Google can determine this is this, it can find it can already index all the videos that are of the same game. That's easy. Then it has to fingerprint the actual digital video of the level you're on against other videos to figure out which video is the same, meaning the same location in the game, and then it shows it to you in a YouTube video. This is not easy. This is very difficult to do. So the engineers who worked on this and applied the machine learning and the algorithms to do this, it's amazing. But just think about that, right? How easy is it now when you get stuck on a game for you to just tell Google Assistant, hey, how do I get past this level? Or how do I beat this tomb? And it just shows you a YouTube video so you can get past it. That's pretty impressive. So the last couple of slides here I'm just going to show you are, information in terms of if you want to find out more. Google Stadia on Facebook, at Google Stadia on Twitter, Google Stadia on YouTube, and then just hashtag Stadia for everything. I've already followed all of these. There's not any more information coming out right now, but I have a feeling they're going to launch this year. We don't know when. They didn't say. If I had to speculate, I'm going to guess it's going to be in fall. And here's the reason why. The end of the year is typically where the consoles really put all of their titles, right? And the reason, the big titles, not all the titles, I should say, the really big, your big blockbuster of the year is usually going to come on or around Christmas time, right? Let's say Thanksgiving time. And the reason is simple. They want to sell more consoles. So they figure if they put out their best game that people who don't have that console yet, or maybe don't have the upgraded one. So let's say you have a PS4, but you don't have a PS4 Pro. Well, we're going to put out a game like God of War. And I don't remember when God of War came out. I'm just using it as an example. And this thing runs amazing in 4K, right? So they're going to say you can play it on PS4, but it really looks great on PS4 Pro. So you as a gamer say, you know what? It's Christmas time anyway. I'm probably going to get something. So I'll just get a PS4 Pro and then get God of War and be happy. I think Google wants to preempt that. My guess is that they want to come out before that actually happens, so that they're not sitting there, trying to compete with all the consoles at the same time. I'm gonna say fall. I'm gonna say August, September-ish, maybe October, to try to get everyone onto it and experiencing it and playing games on it before the consoles get their big games out, and then try to push consoles. Because think about what Google's looking at here. If we can get the gamer on our platform in September or October, and it's awesome and the experience is amazing, when the Christmas time comes around, they're going to look over at that PlayStation or Xbox and be like $400 versus nothing, or maybe there's a monthly fee of $20. They're going to be like $20 versus $400. Yeah, I think I'm just going to stay with Stadia, right? And this is going to be a pattern happening over and over. And this is why I think that consoles are eventually going to die because of streaming services, because people, it's a lot easier for someone to spend $20 a month or $30 a month, whatever, to play games than to, shell out $300, $400, $500 out of their pocket, right? For a console. That doesn't even include the games, right? So, I'm guessing fall. I could be wrong. It says 2019. They have up until December, so we'll see what they do. These are a couple of websites you can go to, stadia.dev, stadia.com. So I already went to stadia.com and signed up. If you're interested in Stadia, I recommend you go sign up as well. Stadia.dev, I still need to go sign up for it because some of that data is going to go in part 3 of this video, covering this from a developer perspective. We still have a whole section that hasn't been touched yet that has to do with developers, and I realize that this video is already over an hour at this point. But hashtag Stadia, right? Look all over, look on Twitter, Instagram. As they start releasing information, you'll be seeing it under that hashtag. And that's about it from the Stadia presentation. So here we have a little outro video, and then I'll be right back after that.
Thank you very much for gathering around with all of us today. With Stadia, we can all dream bigger and together build a playground for every imagination. Thank you.
So how did y'all like that little outro? Pretty pumped, huh? Well, thank you all for watching the video, and don't forget to like, comment, and subscribe. Let me know what you think about Stadia, especially the technical deep dive we did in the engineering. Ask me any questions you want. Remember, I don't work for Google, so I don't have any kind of insider information, but I'll answer the best I can. Also, don't forget to follow me on all the socials: Twitter, Instagram, Facebook, Mnemonic Tutor. Also follow me on Twitch, Mnemonic Tutor, but that may change very soon as I may be streaming on YouTube thanks to Stadia. And as always, I'll catch you guys in the next video.